Last time we were going through the concepts related to signals. Okay, so we discussed the different types of operations we can do with the signal. We discussed about signal coordination. Okay, some of the important concepts like saturation headway, saturation flow rate, okay, clearance time, loss time, and these things. The last thing which we did was this example in which we were required to calculate the capacity of one approach of the signal, okay, and we did it using two methods. The first method was involving the saturation headway, and the second method involved the use of saturation flow rate. Okay, now we will do something more which is also related to saturation headway, okay, which is to calculate the capacity of the whole intersection. In the previous example, it was capacity of just one approach, one direction. Now we are looking to calculate the capacity of the entire intersection. Okay. So first thing is the loss time. TL is the total loss time in one phase. Okay. In one phase, we have loss time of TL. TL includes two things: clearance loss time and startup loss time. Clearance loss time means what? All red. And startup loss time means what? All green. Huh? Yes. Okay, good. Good. But this is taken by which vehicles? If you want to measure it, then you will be looking at which vehicles? No, before the fourth. The loss time is before the fourth. Okay, so the first 3-4 vehicles take some extra headway. That extra headway is startup loss time. Yes, it is in green, but there is no all green. Okay. I said it. You guys will write in the exam and then you will say, Doctor, you said it. So I'm telling you, it's not all green. Okay. So TL is startup loss time plus clearance loss time, but this is for one phase. N is number of phases you have in one signal, because one signal has different approaches, right? Different directions. For each direction you need a phase. Each direction has to have green and yellow and so on. So N is the number of phases you have for the entire signal. So N into TL means total loss time of one cycle. Okay. One phase has a loss time of TL and one cycle has N phases. So TL multiplied by N gives you total loss time for the entire cycle. Okay? Then I want to calculate the loss time for the entire hour. So C is my cycle length, time taken for one cycle. So if C is the cycle length, time of one cycle, then 3600 upon C is what? It will give me what? Number of cycles. I didn't hear it. Number of cycles. Number of cycles in 1 hour. Okay. So L was for one cycle and 3600 upon C means number of cycles in 1 hour. So L into this will give you loss time for the entire hour. Okay. 3600 is what? Yes. Yes. So total time of the hour, right? Total time of the hour. I'm hearing some weird answers. Like you guys can improve on anything on the downside, right? My student said 3600 is time of 1 day. 1 day has 3600 seconds. Okay. So anyways, that's why I keep on asking. 3600 is the time of 1 hour. Within 1 hour is 3600 seconds. Okay, according to normal people. Divide by time of one cycle. So total time divided by per cycle time will give you number of cycles. Multiply by the loss time of one cycle, it will give you loss time of the entire hour. Okay, so LH is the loss time of the entire hour. Okay, so TL for one phase multiplied by N becomes one cycle. Then L for one cycle multiplied by number of cycles becomes for 1 hour. Okay, clear? Yes, one traffic light. Yeah, one signal. Yeah, one traffic light. All means what? Which one? L is for the all directions.
Why do we calculate it only for one signal? Shouldn't we use it for all the signals too?
What do you say is a signal?
For all the intersections.
All intersections, like if there are three, all three of them, like this.
We have 4 perpendiculars in each intersection. So
It's called one signal. It's called one signal. For us, as per the design, it's one signal. Because all traffic lights are operating on the same cycle length. They are not independent. Got me? Okay. So this building has a structure, right? Okay. And this structure is connected. So you cannot take one floor at a time. But each floor has a structure, right? But when you are designing, you will design the entire building. Same thing here. On the field, it looks like 4 signals. They are not 4 signals for us because we are designing it as one unit. Okay, so cycle length is for all. When I said all directions, it means according to you all signals. Okay. All lights on one intersection. Okay, the total time for them is C. Okay, and the total loss time for them is L. And in 1 hour, you will have LH. Clear? Clear? Keep on reading this.
number of
Phases.
signals.
It could be. It depends how you want to show it. Sometimes there are 8 signals, but we have only 4 phases. It can happen. So 2 lights go at the same time. So there are 2 signals, but phases 1 because they are going at the same time. Got it? Okay. Now, then we have, so I got loss time for the entire hour. Okay. Then this is the effective green time of the entire hour. Effective green time means what? The time during which vehicles are moving at saturation headway. Okay. Effective green time is the time during which vehicles are moving at saturation headway. Now this headway is minimum or maximum? Yes. You ask. No, you have them. Minimum or maximum?
Minimum.
What is this? You are understanding? What is it? I'm looking at him. That means I'm asking you. Tell me, you have to tell. Minimum, maximum. You have to pick one. Otherwise, you will be in that. Yes, minimum or maximum? Minimum, good.
I didn't know what.
Huh?
I just did that.
You know, right?
Yeah, you said this before.
That, yeah, okay. Because I said so. Okay, so minimum headway. Okay, saturation headway is the minimum headway. Okay, so when you subtract the lost time from the available time, the remaining is called as effective green. Okay, when you subtract the lost time from the total time, after subtraction, the remaining is called as effective green. Okay, so this was a lost time of 1 hour. You subtract it from the hour, you get effective green of 1 hour. Clear? Okay, and I said during effective green, the vehicles are moving at what headway? Saturation headway. Okay, so total time divided by headway of one vehicle, it will give me what? Number of vehicles. Total time divided by interval per vehicle, it will give me number of vehicles. Clear? Okay? Clear or not? If headway is minimum, then VC is maximum, right? They are inverse, right? If I put minimum headway, which is saturation headway, I will get maximum volume, right? Maximum volume. Or what do we call maximum? Clear? Clear? Any questions? So this equation VC equals to Tg by H is an equation of capacity for the intersection. Clear? Clear? Very simple equation, right? Very simple, very cute, right? We don't want this. Okay? We don't want this. So tell me, does Tg have an equation? Does Tg have an equation? Or not? It has, right? It has. So I can replace Tg with the equation of Tg, right? Okay? Now in that equation you see Lh, right? Lh has an equation or not?
Yes.
I can replace Lh with the equation of Lh, right? In the equation of Lh we have L, right?
Yes.
So I can replace L with the equation of L or not? I can, right? I can do all these things. Okay? And I will obviously. So this is the scaling monster we have created. Okay? So the equation was Tg upon H.
Or we can just follow the steps step by step and then we can
Yes.
like this.
Before the steps, I have to give you 5 equations. Why would I give you 5 equations like this? Makes sense, right? Okay. Now look at the equation. In this equation, there are 2 values which depend upon the drivers or the intersection design. I cannot change. For example, headway. How much intervals the driver will keep between them is up to them. I can observe it. I can go to the field and note it down, but I cannot change it. Okay, I cannot force the driver. Okay, when you go for your lessons, they try to tell you, right? Keep distance, and you don't listen. So we cannot change. The other thing is TL, lost time. Again, the first 3-4 cars, how much extra time they are taking, I cannot change it. Okay, all red time depends upon the intersection design. I cannot change it. Okay, so what are the remaining items now? Huh? Cn, H is head I cannot change. Cn, N. Okay, C is
Cycle length.
cycle length. Cycle length. Yeah, capacity also comes with C, I know. And CAT also comes with C. It's not CAT or capacity. Okay. It's cycle length. Okay. And then we have N. N is
Number of phases.
number of phases. Okay. So these are the things we can change. This is part of our design. Designing signals, you can play with the number of phases, you can play with the cycle length. Okay. Now look at the equation. N is a negative term, right? N is coming in the negative term. So if I increase N, what will happen to VC? It will decrease, right? You increase the negative term, VC will decrease. Okay. C is in the denominator of the same term, right? C is in the denominator. So if I increase C, VC will increase. VC will, that's in the denominator, right? If you increase this, negative term will decrease and VC will increase. Okay, got it? Which is what they are showing here. Cycle length increases, VC increases. Okay. Number of phases increase, VC decreases. Clear? Clear? Okay. Where is the maximum value here, right? This is my maximum value, right? How many phases? 2. Cycle length very high. Whatever the value is, we don't know the value, but very high. Okay? 2 phases. Now each phase is what? As you said, 1 signal, right? Each phase is, let's say, 1 signal. Okay? So you 1 movement. Now okay. When I was saying movement, you wanted to say signal.
I didn't know.
Okay. So 2 phases means what? Okay, signal will become green for 1 direction. Okay. 1 phase, then it will become green for the other direction. 2 phases. What about the rest? The other direction, right? What about them? So you see the problem now. We will discuss when can we give 2 phases and so on. But you see the problem now. 2 phases means what? It will be only open for 2 directions. Okay. The rest of the directions we have to merge or block or whatever. Okay, so you see the problem now. I have an intersection and the signal only has two phases, so where will the other people go? Okay, clear? So two phases has a movement problem. It has lot of restrictions. I cannot just apply it wherever I want. I will show you the case, no problem. With two phases. Okay, so but you see the problem. If I keep on giving two phases everywhere because I'm getting maximum VC, it will create a problem for me. It's not possible every time. Okay. What about maximum cycle length? So I have four phases, which is very easy to understand. Four directions. Each direction has its own green. Four phases. Okay. Clear? So I take four phases, but I make the cycle length maximum. Okay. Now increasing the cycle length means you are giving more time for the vehicles to move, right? So more time means more capacity. More time means more capacity. And more phases means what? With each phase, you see you are multiplying what? Lost time. Each time the signal becomes red, there is clearness loss time. Each time the signal becomes green, there is startup loss time. So if it happens 2 times, you will have lost time twice. If you have 3 phases, the signal will become green and red 3 times. So you will have the lost time 3 times. Got it? Okay, so increasing number of phases increases lost time. And increasing the cycle length increases the total time. So when you increase total time, you get more capacity. But when you increase the number of phases, you are actually increasing the lost time. So that's why your capacity decreases. Okay, got it? Okay. So whatever the number of phases are, can I keep on increasing the cycle length to whatever value I want? The answer is no. Okay, there are limits given in the books and standards about maximum cycle length. Okay, but why these limits are given? If I can just keep on increasing the capacity with the increase of cycle length, then what is the problem with them? Why would they have a problem if I am getting more capacity? The problem is more cycle length means more waiting time as well. So when you increase the cycle length, you will increase green time as well, right? You increase my green time, I'm in one direction, right? That means what? My green time increases, for others, red time increases, right? When I have green, they have red, right? So my green time increases, their red time increases, okay? So for example, you are on a signal turns red, after 30-40 seconds, it turns green for you, you move. Waiting time, 30-40 seconds, no problem. Okay, now let's say it's 2 minutes now. Now it's, you just came and it's now red. You know you have to wait for now 2 minutes. Until 2 minutes there is no chance. Okay, even if you don't, and it may happen that after 2 minutes you move, but you don't cross, right? It can happen. But after 2 minutes you moved. Okay, less problem. And now imagine that the signal becomes red for 5 minutes. Okay, big problem, right? Now you know if I don't pass now, next 5 minutes I will not even move. Okay, you get the problem now. Okay, so it will make the drivers restless, which you guys already are. It will make you more restless. Okay, and then what will you do if you see the signal yellow? Ahmed will tell me. Ahmed. You see the signal yellow. Mm-hmm. Pass, right? In the last lecture, she was saying, I will think, right? Now you will not think, right? Now you will not think, right? Okay? So everybody will become Ahmed, which we don't want. One is enough, right? Okay? So, decreasing number of phases has a movement problem. Okay? You cannot accommodate all the movements if you have less phases. Increasing cycle length, then you are playing with the drivers now. They will become restless, they will take more chances, and so on and so forth. Okay? And they become from here and here. Okay? Everything is open then. Okay. Now, VC is the volume. I'll design for VC, right? VC is the volume. I'm designing what? I'm designing cycle length. I'm designing a signal, right? I'm not designing volume. I'm designing signal. Okay. So first thing, I have this equation for VC. I will flip it for cycle length. Okay. I'll flip it up for cycle length. So this now equation is for designing the cycle length. Okay. Designing the signal. Clear up till now? Now, VC, in this equation I have VC. VC is the volume. VC is volume. I want to convert it to flow rate. How do you convert volume to flow rate? Peak hour factor. Okay. So I will divide it with peak hour factor. This will convert volume to flow rate. Okay. I'm designing for VC. VC is my design value, right? Okay. This is a 400 level course. You must have taken other courses in structures, right? So when you design a building, you calculate the load. Do you design for the exact same load? No. You design for what? With a factor of safety, right? So I need a factor of safety here as well. I cannot design for exactly VC, which is the actual value. I need to design for more. Okay. So my factor of safety is called as V by C ratio. Factor of safety is what? V by C ratio. Where V is what? V stands for volume and C stands for capacity. Yes. Okay. Now what we want to be more? Volume or capacity? We want capacity to be more, right? So V by C ratio will be more than 1 or less than 1? Less than 1. So it's in this range. Okay. So I have the equation for demand. I flip it to get the equation for cycle length. Then this equation I will divide VC with two things. Peak hour factor, so VC becomes flow rate. And then V by C ratio as a factor of safety. So V by C ratio, the range is this one. Clear? Any problem? Any questions? Okay. Sorry?
The cycle length, it will depend on the number of phases we have.
Yes.
So it is not for one second from red to red, right?
Huh?
It is not from red to red for one direction, right?
No. Red to red is all directions finished. The signal turns from red again to red. That means all phases have finished. Okay. Now, 3-phase signal, lost time 4 seconds per phase, saturation headway of this much, peak hour factor is given, VC is given. We want the desirable cycle length, which is the equation with all the factors. Okay, they are saying change the V by C ratio. Okay, everything else is constant. V by C ratio will change from 0.8 to 1. Okay, so calculate different values of desirable cycle length using different V by C ratios. So V by C can be 0.8, 0.85, 0.9, 0.95 and 1. So what will be my desirable cycle length for each case?
And it is a value.
How much?
Minus 648.
Okay, next.
489. 989.
Any problem? Yes. Clear? Clear? Okay. Now, first of all, the negative value. It's in seconds, right? It's in seconds. Having negative time is our dream, our wish. If time can be negative, we can go back to our childhood. Okay? There was no Dr. UNAP, there was no UOB. We were very happy. Right? No IC, very happy. Okay? So negative value, not possible. We cancel it. Negative value, cancel. Gone. Clear? V by C increases cycle length. Huh? Cycle length what? Decrease, right? Why cycle length is decreasing? V by C increases means capacity is reducing, right? Factor is increasing means capacity is decreasing. And I showed you the graph. Less cycle length, less capacity. So more V by C ratio means less capacity, and less capacity means less cycle. Clear? Clear? Okay. Now look at the last two values, or any of the values. This one is 84, this one is 64. 84 point something, 64 point something. What will be your last value, final value, if you want to just get rid of the fractions? 65 and the first one? 85 or 84? 84? Rounding up. Rounding up. 85. This is design, right? You cannot go below the design. Okay? Always rounding up. Okay? And even we round up not to the nearest number. We round not to the nearest 5 or 10. Okay? So even yeah, they are to the nearest 5. But if, for example, this one, 126.8, if even this one will become 130. Clear? Okay. Okay. Second example, we have volume given on the intersection. We have a cycle design given. Signal is already designed. They are asking for two things. First of all, find out number of lanes. For this design and for this volume, how many lanes you require? First thing. Okay? Clear? Second thing, once you finalize the number of lanes, you can redesign the signal now. Recalculate the cycle length. Clear? First of all, use whatever is given to find out number of lanes. Once you find out the number of lanes, you can readjust or adjust the cycle length. Okay, so we have two things. We cannot play with both of them at the same time. So we'll fix one, calculate the other. When the other one is fixed, we will adjust the first one. Clear? Okay. Understood? So the first thing I need is, there's already a cycle length. This cycle length can handle how much volume? This is the first thing I need to know. So I'll take this equation. I'll put it over here. Tell me, how much of the volume this cycle length can take? Yes, how much? So my VC is 1357 vehicles per hour. Right now I can handle this much. Okay? With the current design I can handle this much. But how much do I actually have? How much do I have? 1800 and 1200, right? Total is? Total is how much? 3000, right? Okay. Now when you said 1800, we said 1800 will pass one by one, right? One after the other. So we are assuming how many lanes? Huh? One lane, right? All 1800 will pass from one lane. Okay, so 1800 one by one. I need the time for full 1800. Okay, and same thing for the other direction, right? 1200 all pass one after the other, so I need the time for full 1200. Okay, now let's say I put two lanes in the in the east-west direction. I put two lanes in the east-west direction. So the total was 1800. Now it will divide. Okay, so each lane will carry how much? 900. Two cars will pass simultaneously. So I don't have to worry about 1800. I have to worry about how much? 900. Got it? Okay. So if I have two lanes east-west and one lane north-south, then how much do I have? How much is my VC? I have 900 in the east-west and 1200 in the north-south, right? Total how much? Okay. In the east-west, I have two lanes, so each will carry 900. And the north-south, I still have one lane, so that one will carry 1200, right? 1200 plus 900, total 2100. Okay. But how much is my target? 1300 something, right? So the value is still above my target. Okay, so I need to change it. I need to add more lanes. Okay. Now in the east-west, each lane is already carrying only 900. In the north-south, the lane is carrying 1200, right? So I should increase the number of lanes where? North-south. So north-south will become how much now? 600. So how much then? 600 and 900? 1500. Problem solved or not? No. So where should I increase now? East-west? Okay, east-west, because one lane is carrying 900 still. Okay, so if I make three lanes, total was 1800. It will be divided into three lanes, so 600 each lane, right? And north-south is still two lanes. So 600 from there, 600 from there. 1200. Problem solved or not? Solved?
Why would we add opposite directions with each other?
Huh?
Why do we add opposite directions with
Because this is for the entire signal, for the entire cycle. In one cycle, both directions have to go at some time, right? This is the total of both phases. Clear? Okay. So first part done. What was the first part? Find out number of lanes. Okay. How many lanes? How many lanes? Yeah, 5 total. 3 in one direction, 2 in the other, right? Okay. First part done. Second part was recalculate the cycle length. Okay. So now I will go to the equation of cycle length. This one. Okay. Very messy. Okay, give me desirable cycle length and I'll try to put it somewhere. I don't need this one. Okay, but my VC is how much now? My VC is this one, the actual one, 1200. With the number of lanes which I fixed, my VC is 1200. Okay, so how much is the cycle length I need?
So,
77.4. Okay, and as I said, you can make it 80 or 85. Clear? Any questions? Okay. Now, let's say you take this design to the client, okay, and he says we don't have enough space on the road to make 3 lanes in any direction. So the maximum you can have is 2 lanes. And less than 2 lanes, I know this was a problem, right? Even 2 lanes is a problem. But what can I do? Okay, now the client is fixing the number of lanes. So with 2 lanes in each direction, my VC is how much? 1500. So what I can do is, I cannot change the number of lanes. So let me now change the cycle length according to the number of lanes. So you put VC as 1500, how much you get? Cycle length. Huh? Yes, how much? Okay, so you show this to the client in your face. Take this. And then he will fire you and come to your house, no problem. Okay, relax. Clear or not? So you found the number of lanes, found the cycle length, but there was a restriction. You tried to apply the restriction, but you got a negative answer. Negative answer means what? Not possible. You cancel the value. Okay? Clear? Okay? Can I change something else? Number of lanes I cannot change now. Can I change something else? Number of?
phase.
Number of phases can be changed, yes. Or V over C ratio can be changed like we did in the previous example. Okay, so these things can be changed then. Clear? Okay. Now, yes. Now in this example, we were increasing number of lanes, right? We're increasing number of lanes, and then we divided the volume in that direction. We divided it equally, right? So if you have 1800, you may have 2 lanes, become 900, 900, right? 3 lanes, 600, 600, 600. Why? Because all of them are in the same direction. Okay? So we mentioned about 2 phases, right? That having 2 phases is very difficult. Why it is difficult, you can see in this example. Okay? First of all, you see volume going from west to east. Do you see the other direction? No. So this is one way. Same thing north-south, right? One way. Do you see any turning? No. You see how many restrictions we have to apply. Make both the roads one way, make the turnings, bend as well, and so on and so forth. Clear? So this is why 2 phases is not practical every time. Okay, having more phases becomes necessary. Okay, got it? Now, so going back to the discussion, since I have volume in only one direction, so I keep on increasing the number of lanes and dividing the volume equally. Okay, but what if I have 1 lane going left and 1 for straight? Okay, can I take the total and divide it equally? No, because drivers who want to go left will go left, no matter what you are doing, and drivers who want to go straight will go straight. So you cannot just take the whole volume and divide them equally. Okay, so let's say you have the straight 1000. So in 1 lane 1000. Other lane which is for left turning 200. Which one will you put in VC? 1000, right? Because it's more. Got it? So you picked 1 lane, right? You picked 1 lane, then I will take the value of this lane. So that lane is called as meeting at 3 p.m. Very good. That lane is called as critical lane. Okay, the lane from which you will pick the volume and put for VC. Clear? Or put in your design. Okay, so every phase can have multiple lanes, but you have to pick one of them as critical. Okay, and the timing and everything will depend upon that lane. Okay, now I gave you the example of 200 and 1000, right? So 1000 obviously takes more time. Okay, but what if I have left turning 1000 and straight 1000? Which one is critical then? Which lane is critical then? I know the volume is same, but which lane is critical? Left, right? Because it takes more time. Even if the volume is same, I know the left turning will take more time. And in some cases, even if the volume is less, because of the turning, it may need more time. So 900 left turning may need more time than 1000 straight. Okay, so critical lane, you have to look at which lane needs more time. Another example, you have 3 lanes going straight. Where will be the heavy vehicles? The right hand side lane, right? So that lane may actually have less volume, but because of the heavy vehicles, it needs more time. So that may become your critical lane. Got it? So critical lane doesn't mean the one with the highest number. The critical lane means the one which needs more time. Got it? Clear? And everything is according to the critical lane then. Once you pick the critical lanes and took the volume, the signal time is according to the critical lane volumes. The green time is according to critical lane volume. The lost time, if you want to go and observe the lost time, again for critical lane. If you want to observe the headway, critical lane. Okay? Every phase has a critical lane and all the calculations are according to the critical lane. Okay? Yes. You cannot have more than one critical lane in one phase because you are designing, right? So you cannot design for 2 values at a time. You have to design for 1. Okay? So there cannot be more than one critical lane. Then from the total time, if you subtract the lost time, in the remaining time, whatever remaining time you have for the signal, in that time at least one critical lane should always be open. Okay? So outside the lost time, at least one critical lane is always open. Okay? Clear? Outside the lost time, at least one critical lane should be having yellow or green. You have a signal cycle. Signal cycle has lost time, right? Startup lost time, clearance lost time. If you subtract them in the remaining time, so the let's say cycle length was 80 seconds. Lost time is 10 seconds. So remaining 70 seconds, right? So there should be a time period of 70 seconds where at least one critical lane has green or yellow.
All of them have green.
Huh?
All of them have green at that time.
How can all of them have green? They are in different phases. Each phase has a critical lane. Each phase has a critical lane. All lanes in one phase are not critical. I have a phase which is in this direction. It has 3 lanes. One of them is critical. I have phase in the other direction. And that has 2 lanes. So one of them is critical. Okay. So at least one critical lane will open. Got it? Okay. Now, I said at least one critical lane open because you can have more than one critical lane open as well. We call them overlapping phases. 2 phases which have a common time, which have a common interval. Overlapping is you have 2 phases or maybe more than 2 which have a common time interval. Okay. For example, straight and left. Straight and left. So both of them start at the same time, but left one will finish first and the straight will finish later. Got it? So this is overlapping. Both phases started together, this is overlapping. They have a common time between them. Okay, so a straight phase will have a critical lane and the left turning will have a critical lane. So we have 2 critical lanes open at the same time. It can happen. It happens with overlapping phases. Okay, so for overlapping we have different options. First of all, overlapping means my total time is less. If I do overlapping phases, then I'm allowing more vehicles at the same time. So for total volume, I need less time. Okay, because people from different directions are going at the same time. So overlapping helps me reduce the time of the signal. Okay, but overlapping can have different options. I just gave you one option, right? Straight and left. The other option is 2 straight at the same time. The other option is 2 left turnings at the same time. Okay, so this two straight, 2 left turning, okay, and straight and left turning. These are different overlapping phases, okay. So which one will you go for? You have to look at the summation of volume in each case. Whichever gives the highest summation, I will go for that. For example, let's say this is 600, this is 500, this is 300, yep. Okay, this one is 300 and this one is, let's say, 500. Okay, so you have, if you do a straight and left, you have 600 plus 300, total 900, right? If you do 2 straights, 600 plus 500, total 1100. If you do 2 left, you have 500 and 300, total 800. Which one is serving more volume? 2 straight, right? With 1100. So which overlapping is more beneficial? Okay, so this is how you decide which overlapping option is more beneficial. You have to look at the summation of critical lane volumes from all phases. You add them together and you see which one gives you a higher sum. Clear? Any questions? Okay, thank you.